Foundations of Amateur Radio. Today I want to raise the topic of batteries, specifically sizing the battery. You can do this as I did naively. Look at the manual, see the current consumption of your radio is 22 amp, decide that this means that you need to get a 26 amp hour battery to use your radio for 1 hour. Being the portable type, I got 52 amp hours in total. Some time has passed since I made that purchase. I've learned that I can get a lot more out of my battery than 2 hours. I also learned that lugging 56 amp hour around is not fun. Having learned this, what could I have done to improve? Well, first of all, the 22 amp is for transmit. According to the manual, on receive it's only using 1 amp. If you're not transmitting all the time, then you're not drawing 22 amp the whole time. The ratio between send and receive is the duty cycle, often expressed as a percentage of the time spent transmitting. Another thing to note is that 22 amp is when you use full power for a particular mode and band combination. On my radio, that's 100 watts, HF FM, so only using 5 watts will reduce the power consumption radically. Speaking of which, my radio has different maximum power levels for different bands, so when you're doing the maths you need to take that into account. If that didn't add enough complexity, different modes use different amounts of power. AM, FM, RTTY and other digital modes use 100% duty cycle. CW uses 40% and SSB only 20%. So rough back of napkin calculation using 5 watts SSB on HF for an hour, transmitting only half the time, gives you 22 amps times 5% power times 20% SSB times 50% of the time, a tenth of an amp. Now before you go out and buy a 1 amp hour battery and expect to use it on HF for 10 hours, there are some wrinkles. First of all, a 12 volt 26 amp hour battery doesn't actually give you an amp per hour for 26 hours at 12 volts. It's graded on a scale. At the beginning it gives you a higher voltage, and at the end it gives you a lower voltage, and after a certain point you've actually destroyed your battery, not to mention that the radio stopped operating when the voltage went below 11.7 volts, somewhere around 30% capacity. To make things even more interesting, different batteries react differently depending on how fast you're drawing from them. Another issue is that temperature affects how much power you're able to draw. After all that, the manual for your radio is specifying theoretical numbers, not actual ones. I've never ever seen my radio draw 22 amps, even when it was running flat out. On the flip side, I've also never seen my radio draw less than 4 amp when transmitting. So the maths for this doesn't add up as expected. So why was I giving you the maths if it doesn't work out? Because Simple Simon Says solution doesn't work, but neither does some educated calculation. I hear you saying, well, that wasn't helpful. Well, actually it was. Now I can tell you something and you'll know why it'll help you. Get yourself a power supply with a display that shows amps, or get yourself an ammeter and stick it into the power supply circuit and take some measurements. Use a dummy load as the antenna, since SWR will also affect these numbers, as does the microphone gain, the squelch level and the volume level, as well as the display on your radio, the tuner and other things you have connected. Theory is great. Practice in this case gets you a lot more reliable result. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.